Okay, so for the first one here, we're asked to find the area. So we're going to divide it up into rectangles. There's two ways we could approach this. We could fill it in, find the big rectangle and subtract out the little piece. That would work. Or we could divide it up into smaller ones and add them together. Let's divide this up here into small pieces. Piece 1 here is how big? 5 by 16, which is 80 square feet. Piece 2 here, we need to find some dimensions. This dimension here, we have to assume that's 10 feet as well. How big does this have to be? 6 feet, yes. We got 16 here, minus 10 leaves us with 6. So that is 6. We got to find this dimension. Yeah, we've got 2 and 5. Whatever this is has to add up to the 12, so that's got to be 5 as well. So that's 5 feet. So this piece is 5 feet by 6 feet, or 30 feet squared, 30 square feet. Then finally, this third piece down here is 2 feet by, that's 16 still, or 32 square feet. We add those all up, 142 feet squared. Any questions on that? Of course, we could have done it as 12 by 16. Is 192 square feet. Then we find that this is 10 by 5. So we subtract out 10 by 5, which is 50 square feet. Still gives us 142 square feet. Better get the same answer either way. On the second one over here, for the volume, remember, to find the volume, we first have to find the area of the base. The base on this is going to be this top piece here. I can go ahead and do either method that I just did over here. I can make it a big rectangle, find that area and subtract it out. Or I can divide it up into smaller rectangles. Let's start with the big one here. The big piece here, the big purple rectangle, would be 12 by 8, which would be 96 inches squared. The piece that's missing here is 5 by, what's this dimension? 6. We've got 12 across here. 4 and 2 make 6, so the rest of this has to be 6 to add up to 12. So that's going to be 5 by 6 is 30 inches squared. We are subtracting that piece because it's missing. 66 square inches is the area. So to find the volume, you take that area times the height, which is 5. Gives us 330. That's now inches cubed. Inches squared times inches is inches cubed. Does that make sense? You could have also divided it this way to get that 66 square inches. This piece is, of course, 4 by 8, which would be 32 inches squared. This piece here, this is 6. This has to be 3. 3 by 6 is 18 inches squared. And this here is 2 by 6, so 16 inches squared. That does add up to 66 if we add those up. It comes up the same. Any questions on either of those first two? How many of you had both of those right? Cool. Number 3 here. Calculate. This is an order of operations question. Now there's no enclosing symbols and there's no powers or roots, no exponents. So that means we can jump straight to multiplication and division. What are we going to do first? Yeah, we're going left to right. 4 times 5 is 20. What's next? 2 divided by 10 is or 20 divided by 10 is 2, sorry. And then 2 times 4 is 8. And then addition and subtraction, we're going left to right. 9 plus 2 is 11. And then 11 minus 8 is 3. Any questions? Yeah. So what we're going to look at today, we mentioned it a little bit yesterday with our areas and volumes, and that was using formulas. And the formula we used yesterday, of course, was just, first of all, the area formula, where area is equal to length times width. And we gave you that rectangle. We gave you information like 15 inches by 6 inches. And we had to plug that into the formula to find the missing number. For what we're doing here so far, the missing number is always going to be the one that's by itself. Thank you. So here we would put in 15 inches for L times 6 inches for W, which 15 times 6 is 90 inches times inches is inches squared. So our area was 90 inches squared. Well, there are other formulas, other areas that we can work with that might be more or less complex. One of them is the area of a trapezoid. A trapezoid is similar to a rectangle in that it has 4 sides. Also, a rectangle, both pairs of opposite sides are parallel. In a trapezoid, only one pair of opposite sides is parallel. Those 2 sides are parallel. These sides obviously are not. In a trapezoid, you have 2 bases. So that's base 1. This is base 2. I'm going to label them A and B. Then we have the distance between them, which is our height. Notice I've got little boxes here that signifies a right angle. Distance is always measured at right angles. So the distance between 2 lines will form a right angle with both lines. The formula for the area of a trapezoid comes from the fact that we know how to find the area of a rectangle. And we can turn a trapezoid into a rectangle rather quickly. I can go halfway down this slope surface here and cut this off. This little piece will flip up and fill in that hole, making that end of it square. I can do the same down here. I can go halfway down that little slant and cut this off. That little piece will flip up and fill in that end. I've now created a rectangle. The rectangle has a length that's somewhere between A and B, between the 2 bases. The height, or the width, is still the same as the height of the trapezoid. So that's still H. This here is somewhere between A and B. In fact, it is exactly between A and B. How do we find a value that's between 2 other values? We add them together and divide by 2. We average them together. So the area of a trapezoid comes from our rectangle area formula. We just put this in for the length. So it's A plus B over 2, or the average of the 2 bases, times, instead of width, we call it a height in a trapezoid. So if I have a trapezoid that's 24 inches here, and we'll go 14 inches here, and we'll go 12 inches here. to find its area. What's going to go in for A? 14. What's going to go in for B? 24, and that is all over 2. What goes in for H? 12. Now the parentheses signify we have to do something there first. The fraction bar is also an enclosing symbol. We have to do the top first if there's anything to do, and then the bottom if there's anything there. Then we can divide. So on the top there, we're going to add. 14 and 24 makes 38. And then we have 38 divided by 2, which is 19. Now we're down to a single number in the parentheses. I don't need the parentheses anymore. What is 19 times 12? 228. Now the units on that's going to be inches squared because it's an area. If you are going to punch this in your calculator, by the way, bit of a warning. You can do 14 plus 24. Before you hit divide by 2, what do you need to make sure you do? Yeah, hit equals, yes. Then divide by 2 to get the 19. Then times 12. If you just punch it in without hitting equals, if you do 14 plus 24, then hit divided by 2, it's going to give you something strange like 26. The reason is order of operations says you divide before you add. So without hitting equals, your calculator is going to divide the 24 by 2 and then add it to the 14. So be careful with that. You have to hit that equal sign. Or the alternative would be you could put parentheses around it. I forgot to hit divide there. You could do parentheses 14 plus 24, close parentheses, and then divide by 2. And that'll work out as well. So just be careful with those. I'll have you guys try one in your notes. I'll have you try that one quick. We'll talk about it in this. So what goes in this one for A? 8. What goes in there for B? 20. And H? 10. So we have 8 plus 20 is 28. Still over 2. 28 over 2 is 28 divided by 2 is 14. We don't need the parentheses anymore. 14 times 10 is 140. What unit should go on there? Feet squared. Very good. Well, there are a lot of other formulas we can deal with. One is the formula for work. Word, that's work too, right? Work is defined to be the amount of work done. Scientifically is defined to be the force applied times the distance moved. F times D. So if you have a box that is 200 pounds and you lift it a distance of 3 feet, the work done, the work performed, what goes in for F? What's the force? 200 pounds is your force. Times what goes in for D? The distance is 3 feet. So then we multiply. Yeah, 200 times 3 is 600. Pounds times feet is pound feet, or usually listed as foot pounds. Those of you in automotive, you're going to look at torque wrenches and torquing things. This is also a definition of torque. That funny looking T is the symbol for torque. Bless you. And torque is The exact same formula, force times distance. The only difference is there, rather than being in a straight line, what that's talking about when you're torquing, let's say you've got a bolt that you've got your wrench on. What that's measuring is the amount of force you're applying here and the distance away from the center of that rotation to where you're applying the force. So it's a weird thing. If you have a shorter handle, it takes more force to give you the same torque. Longer handle takes less force to get the same torque. So let's say you have a 2-foot handle and you're applying 30 pounds of force. What is your torque? Yeah, 30 pounds times 2 feet. 30 times 2 is 60. Pounds times feet is foot-pounds. So yes, it's 60 foot-pounds of torque. If you had a 3-foot handle, of course, you wouldn't need to push quite as hard. Velocity is just a scientific term for speed. Technically, velocity is speed, but in a specified single direction, in a straight line. Velocity is defined to be, just like speed is, distance divided by time. So if you go 364 miles in 7 hours, how do we find your velocity? Well, what goes in for D? 364 miles. What goes in for T? 7 hours. So we divide. What is 364 divided by 7? 52. Good. Now, when we multiply or divide, just like up here, we had to multiply pounds times feet to get foot-pounds. When we divide, we also combine the names. Miles divided by hours is miles per hour. Those of you in automotive are going to see this one a lot when you do your DC electrical. You have Ohm's law. Ohm's law and power law. There's several different versions of it. The one I am going to use for Ohm's law is, let's say we want to find the current in a circuit. I stands for current. Is going to equal the voltage, V, divided by the resistance, R. So if we have a circuit that has 12 volts and 4, that little symbol is the symbol for ohms, that upside down horseshoe thing. What's the current going to be? Well, what goes in for V? 12 volts. What goes in for R? 4 ohms. So then we do the 12 divided by 4 is 3. Volt divided by ohm is a volt per ohm, which actually is an electricity defined to be an amp. So your current, I, is 3 amps. Well, we can make it a little more complex than that. Let's look at the power law. So your power law in circuits, the power in watts is equal to the voltage squared divided by the resistance. So let's look at that same circuit. 12 volts, 4 ohms. What goes in for V? 12. 12 squared over, what goes in for R? 4. What do we have to do first on this one? 12 squared, which is 144. And then we can divide it by 4 to get 36 watts is our power. A little bit of a side note, by the way, for you guys in automotive, you won't see a complete circuit drawn out like this because in automotive, everything gets grounded to the frame. Technically, it gets grounded to the block of the car, which is mounted to the frame. But the way it would be drawn would actually be slightly different in automotive. This symbol here that I just put in, that's a ground symbol, so that means it's connected to the frame. Then we got a ground symbol here, which means that's connected to the frame. Well, technically, if they're both connected to the frame connects them to each other. But you usually draw them out with those ground symbols there instead of actually closing the circuit. Okay, well, I've been cutting you guys short on work time the last couple of days. So today I am going to give you a little bit more. We've got about 16 minutes left. In your book on page 22, 1 through 29, the odds, they give you different formulas, and they're having you plug the numbers in. Once you've plugged the numbers in, then you just have to do order of operations to combine them. Those of you in automotive, by the way, I used to teach the automotive electrical for the auto body students, and I used to do some of it for the broadband telecommunications. So if you guys have any questions when you guys get to that part of the course, don't be afraid to let me know.